Hi everyone, and welcome to the Adaptation Co-Creation series. This series is hosted today by the American Society of Adaptation Professionals in collaboration with the American Society of Civil Engineers. Our webinar today is going to be talking about reducing the risk of coastal flooding through redesigned storm standards, updated codes, and new infrastructure design. Before we dive into the meat of today's webinar, I just want to share a little bit about our host organization, the American Society of Adaptation Professionals. Here at ASAP, our mission is to connect and support climate change adaptation professionals to advance innovation and excellence in the field of climate change. We do this through building a network which is premised on open access, being member-driven, supporting reciprocity, something for everyone, not everything for everyone, that you give, you get, everyone gains, and that we build trust, where members can share successes as well as failures, and through that sharing, we're able to advance and accelerate the field and practice of climate change adaptation and resilience. ASAP supports its members through 3 core programs. Our ASAP Connects program, which is dedicated to bringing members together on critical topics ranging from professional education to climate migration, public policy, and justice, equity, diversity, and inclusion. Our Member Voices program, or rather our Adaptation Voices program, where we share member accomplishments, best practices in the field, and we lift up diverse stories of leadership and expertise. And our Adaptation Careers program, which is where we assist members in excelling in their current jobs. We provide mentorship connections, access to peer learning, and opportunities to explore jobs, RFPs, contracts, and other opportunities for adaptation professionals. Our work is underlined through a code of conduct, a living guide on the principles of adaptation, a knowledge and competencies framework for developing trainings and courses on adaptation, and a racial equity statement, which was approved in 2020 under the title of the American Society of Adaptation Professionals, Justice, Equity, Diversity, and Inclusion Statement. This underlies our work and really puts forward that when we take on climate change adaptation, we're doing it with a lens on climate and a lens on justice. In the Adaptation Co-Creation series, you've joined us for the first of our series, and what you can expect to hear over the next year are examples of innovative and effective adaptation practices coming from diverse project teams, which feature the private sector and the relationship that the private sector puts together with the public, with community organizations, with utilities, and with others to really drive adaptation and resilience forward. And we're going to be thinking about justice and equity throughout this series, recognizing that the leadership in the private sector is not exclusive from thinking about the way that climate change impacts all of our communities, and we want to think about that in a holistic and equitable way. You can be joining us through Zoom or through Facebook Live. You can be joining us as a participant. If you're interested in getting more engaged, we have opportunities for sponsorship and for designing this webinar series. And you can do that through either a single session or the full series altogether. A little bit of tech check for today. It looks like everybody's in pretty good shape. We're running this as a Zoom meeting currently. We have asked for microphones to be off. Cameras can be off or on. Our presenters will be having their cameras primarily off, but we will have them back on during our panel discussion. And we encourage you to post questions in the chat and also use the chat liberally for questions, comments, reactions to what you're hearing. We'll be moderating those and then bringing them forward in our Q&A session after our presenters have had an opportunity to speak. With that, I am thrilled to hand this over to Emily Wasley. She is the Senior Project Director with WSP and the President-elect of the ASAP Board of Directors, and she is going to be our moderator for the rest of our webinar today. Emily, over to you.
Thank you, Beth. And as an adaptation professional member of the ASAP Board of Directors, I'm thrilled to be serving as moderator for today's discussion. Our presenters today are going to share with us how revised standards on sea level rise, storm design, and drainage can enhance community resilience and lead to strong relationships between local, regional, and state governments. Our program will include presentations on adaptation leadership from Virginia Beach, Virginia, and Broward County, Florida, followed by a discussion of how lessons from these 2 communities can be replicated through ASCE and ASAP's professional networks. We'll have an opportunity for Q&A with all of our panelists and wrap up with a quick poll, so please stay tuned. We'll start off by hearing from two experts, CJ Bodnard and Dr. Brian Batten from Virginia Beach, who've been working together on the city's sea level WISE project and design storm standards. CJ Bodnard is a registered Virginia professional engineer and is the Stormwater Technical Services Program Manager for the City of Virginia Beach Department of Public Works Engineering Division. He graduated in 1990 from the Virginia Military Institute with a Bachelor of Science in Civil Engineering. CJ worked as a land development consultant for over 20 years prior to joining the City of Virginia Beach in 2015. Dr. Brian Batten is a senior coastal scientist and project manager with Dewberry's Resilient Solutions Group. With over 20 years of experience, Brian has provided technical project leadership to federal, state, and municipal clients, addressing climate and coastal hazards. He provides technical leadership to FEMA as a coastal program manager under the Production and Technical Services contract, and served on the Future Conditions Subcommittee of FEMA's Technical Mapping Advisory Council. Dr. Batten received his doctorate in coastal oceanography, master's degree in marine environmental science from the State University of New York at Stony Brook. Gentlemen, take it away.
All right. Well, good afternoon. My name is CJ Bodner. I'm proud to be here with Brian Batten, and Brian is bringing up the presentation for you. For those of you who have heard us speak before, I will let you know that for Brian and I to speak in only 25 minutes is probably going to be a minor miracle. We're probably going to get cut off. But if I start talking too fast, just throw something in the chat and tell me to slow down, because you can't throw anything at me virtually, which is something I like. Our presentation is about our Sea Level WISE program in the City of Virginia Beach. Brian, next. Just for those who don't know about Virginia Beach, we're in the southeastern portion of Virginia. We are where the Chesapeake Bay meets the Atlantic Ocean. We were established in January of 1963. The entire city encompasses 310 square miles of shoreline, about 38 miles of shoreline. There are 5 military installations located within the City of Virginia Beach. We are the largest city in Virginia with a population over 450,000, and we are growing every year, which is a very good thing for us. Next, Brian. Just to give you an idea of the complexity of drainage in Virginia Beach, the average elevation in Virginia Beach is average elevation is 10. We have multiple ways that water can get into the City of Virginia Beach. It can get in through the Chesapeake Bay, from the Chesapeake Bay through the Lynnhaven Inlet or Little Creek Inlet. The Chesapeake Bay, of course, being the largest estuary in the country. It can also get in through Rudy Inlet from the Atlantic Ocean. And finally, water can actually enter the city through Back Bay and the North Landing River from the Albemarle-Pamlico estuary, which is the second largest estuary in the country. So when you start looking at drainage in Virginia Beach, we're flat. We have lots of impact due to coastal tides. And on top of that, hurricanes come visit us at least once a year. Next.
It's stuck. Yeah, it's stuck. Not sure what's happening here.
So I'm going to turn it over at this point in time to Brian. He's going to cover you all an overview of our sea level rise adaptation efforts. I'm going to come back on when we start talking about incorporating into adaptation. I'm sorry, I'm going to come back on during implementation, but Brian's going to cover the other 3 items for you. And I'm going to turn it over to Brian.
All right, thanks, EJ, and sorry for that little technical snafu there. Got stuck for a second. So we just want to give a 10,000 foot overview of the sea level rise adaptation plan for the city, just to put the context in place, and then talk a little bit about what we did to support stormwater design underneath that study part of the process, how we took that technical information, we got it into the adaptation strategies, and CJ will pick back up on implementation. So we'll start with this overview. This slide talks about the goal and the desired outcomes of the overall study that we set up in 2015. And a lot of times we translate the goal more simply to just saying, ensure the vibrant future of the city of Virginia Beach. And we wanted to accomplish that by understanding what impact sea level rise will have to coastal flooding, quantify that in terms of floodplain mapping, annualized risk in dollars, and then use that information to develop a suite of strategies. We wanted to have strategies that work citywide in terms of policy, but we also, the city is very diverse, and there's 4 major watersheds there, and each one is very different, and it has very different characteristics, from being a resort area to a very rural area with farming. So we needed to be aware of that and accommodate that in our process. And also we wanted to, as we progress through each item of the study, go out to the public, gather their feedback. So at the end of the day, we would have good support to have this adopted by the city. This figure just kind of shows a general timeline of the activities of the study. It took 5 years to go end to end. We started in 2015 with planning. In 2016, we were awarded a regional NOAA Coastal Resilience Grant that helped financially with the city. And then a lot of time was spent working through a policy menu, some technical analyses to support design, which we're talking about today a little bit, and then different kinds of strategies. And we broke these apart piece by piece, worked through them, learned a little bit from each one, and carried that knowledge forward. And then in the last year, we kind of had to pull it all back together again and package it as a single integrated plan to holistically address the issue for the city. And we finalized that up early this year, and now the city's in kind of an implementation phase. So the Sea Level Wise strategy report replaces what was known as the Virginia Beach Comprehensive Sea Level Rise and Recurrent Flood Study. So it rolls off the tongue a little earlier. This report encompasses about 20 technical reports of about 1,500 pages, addressing everything from site level mitigation, defense structures, nature-based solutions, etc. So the report works to tell the story of the study, similar to that timeline, in a way that's very digestible to the layperson, to the general public, to city council, but also has the sufficient detail to allow the city and folks to understand what's going on, and going through the whole of the why are we doing this, what's our motivation, what's at stake, how are we going to approach this as a city, and then getting down to that watershed type strategies I mentioned before and how they'll carry forward. The strategy for the city, it has 4 main components, because it's Virginia Beach is very diverse areas, and we know with the different pathways for water to get in there and the developed environment, there's no single solution that's going to help them avoid the potential losses and issues in the future from increased flooding. So we have a combination of natural mitigations, which is everything from beach nourishment, marsh restoration, living shorelines, engineered defenses, where we have a set of citywide structural strategies that includes storm surge barriers, raised roadways as levees, etc. Those have cost up to $2.4 billion, and there's a set of neighborhood type strategies which address lower level protection in very high at risk areas. And then we get to adapted structures, which is looking at how to avoid developing in high risk areas, how to adapt existing development in those areas, and designing infrastructure and avoiding putting infrastructure in at risk areas. And finally, prepared communities, which encompasses the whole city, and just looking to educate the public on what's at risk and what the plan is, and also have some economic resilience working with the businesses and workforce within the city. This is a map showing different elements of those 4 areas all together overlaid across the city of Virginia Beach. And it's color coded, the map is, to each one of these items. The 2 takeaways we just want you to get from it today is, one, that there's many different options and some of them overlap each other. So we don't have a concrete exact plan that will be carried forward to the letter at this point, but we do understand a number of different options and pathways the city could go down, and some more feasibility assessment, some of which would be done by the Corps of Engineers, would need to be done to make those final decisions. Also, the other thing we want to mention is that behind those 4 large areas, there is a lot of technical analysis that provides very specific site locations where these strategies would work. If we just pull out one of the layers From that overlapping theme, and this one is under adapted structures and its risk mitigation interventions that focus a lot on the built environment. This just shows what we're considering here in terms of site mitigations, from flood proofing, reconstructing houses, elevating structures, green infrastructure, et cetera, some financial incentives, and also a map within the city where we know that we have done analysis and these are cost beneficial to do. And we can drill down further to that watershed level and look at the maps there. And this is the Lynn Haven watershed, which is in the north part of the city. And it's a mixed development watershed with a lot of recreational boating on entrance to the Chesapeake Bay. And here under each of the themes, we can see all the different strategies that were identified. And the plan presents each one of these with some detail in a map form, usually about where it's suitable, some specifics about the project, some relative costs for it, and the benefits of it. So this is kind of how we proceeded through all this effort. And what we want to do now is, just so you can see the overall picture, we want to switch gears a little bit and talk about stormwater design, which is really the focus here. And as we get into that, one thing we want to set up is that our study, which is COUNTYWIDE, it's got the old name here, was going on a sort of a parallel pathway, which with other studies the city was undertaking, which was the master drainage study and the stormwater master plan. And so we were dealing mostly with the coastal hazard and sea level rise, whereas they are dealing with rainfall and runoff. But efforts were undertaken throughout to exchange a lot of information to inform each other to try to derive some of the best outcomes for the city. In 2016, the city faced several very heavy rainfall events. They're described here, many of them over 100-year return period, and this culminated in October of 2016 with Hurricane Matthew, which in parts of the city exceeded a 1,000-year return period for a heavy rainfall event and caused some pretty devastating flooding in the center section of the city, and also in a recently developed affluent neighborhood in the southern part of the city. Two big picture items that this event and this year caused is, one, which has been helpful to the effort as a whole, is it kind of galvanized public and political support within the city for better recognition and addressing flood hazards and flood risks and planning for them. And then also it made the city ask several questions, and these are kind of articulated down below, but in simple terms, are these three events that happen in 1 year, are they statistical anomalies? Are they part of a trend? What's going to happen in the future? And do we need to change our guidance to accommodate this while we're in the process of all these major studies? So as part of our effort, working with the city, we undertook several analyses to inform stormwater design in the context of those parallel kind of pathways and trying to exchange boundary conditions, tailwater conditions, et cetera, to the stormwater effort. This included looking at rainfall and elevated tailwater or coastal storm surge conditions, trying to figure out how often they occurred. We found out more than half the time we have an elevated coastal water level when we had a heavy rainfall. So then we did some joint probability analysis to quantify that so we could have some relationships to enter into the design guidance. The city also faces issues with what are called wind tides, and that's, as CJ was talking about, to the south of the city and that hydraulic connection to North Carolina. So there's times where the winds blow out of the south for several days, and that pushes water up from North Carolina into the southern part of Virginia Beach, which is very low lying and causes some flooding of roadways and homes. And we did some analyses to try to quantify that and address that and limit tailwater conditions down there to address it. And then finally, what we want to really focus on today is some regional precipitation trends, and what we just talked about is rainfall increasing. And just a quick vignette into that, just to show you an overview of what we did there and looking at that issue. We undertook a gauge level assessment at the Norfolk Airport, and then a local level, which we define as kind of the Hampton Roads area, but a little bit beyond that, and also the Mid-Atlantic seaboard, to look at historic trends and heavy precipitation, and using some different measures, understand if there's non-stationarity in there. We found that yes, there's statistically significant non-stationarity And then we looked to the future and pulled in some regional climate models, an ensemble of those so we could quantify some uncertainty there. We bias corrected those to the historical rainfall, and that we used those to, one, look at what's the hit rate of heavy precipitation in the future. Is it going to increase or stay the same? We saw it would increase. And then we also developed some future condition frequency curves. The two outcomes of this were that we could acknowledge that the Atlas 14 guidance that the city was using from NOAA for stormwater design was dated, it's outdated. It wasn't representing current conditions. It was about 10 years old, I think, or maybe a little less, but 10 years, somewhere in there. And then also that we needed some design accommodations, which led to an increase of 20% over the life cycle of the stormwater infrastructure over the existing Atlas 14 guidance. So we had this technical work, and then we had to have some pathways with this type of work, as well with many other things we were doing for the city to get it into an adopted, implemented action within the city's framework. And with Georgetown Climate Center, we went through a process in the beginning of the study to review national best practices and identify a menu of adaptation options, which were refined with some help from what's called the Sea Level Rise Working Group within the city, which is administered by one of the deputy city managers and has representatives from all the major city departments there. So it's a great place to get to disseminate and gather information with a broad viewpoints. We took that information and then we aligned some of that policy with city council goals and engaged the staff again to have some participatory ranking so we could prioritize these actions and get rid of ones that weren't feasible. And we ended up with this report that you see over on the right, which is part of the overall effort and captured kind of within the Sea Level Rise document. Within that report, we have 7 goals that we set up for the city. And under these goals are 29 objectives and like 180 action items. And for the context here, we want to look at enhanced flood resilience of infrastructure, where we had an objective for stormwater planning and management and an action item of high, that was a high priority to update these standards to accommodate these future conditions and kind of ensure that these projects, things the city were building, were going to function as well as they were intended to from design standpoint towards the end of their life cycle. And I'll turn it back to CJ so he can tell you a little bit more about how they did implement that.
All right, so from an implementation standpoint, Ryan, next. 2 weeks ago today, our city council actually adopted our new Public Works Design Standard Manual. The Public Works Design Standard Manual was the first stage of the policy documents. It was one of the first action items that was in there. And what we did is incorporate the information that Brian was talking about sea level rise, rainfall, and I'm going to talk about modeling and tailwater and groundwater here as we go through this portion of what's in our new standards. Brian, next. From a modeling standpoint, we've spent a large sum of money at this point in time creating models of the entire city. Those models are available for design engineers designing both public and private projects to be able to use. And our Public Works Design Standard Manual actually will mandate that any project with a total disturbed area greater than 20,000 square feet will be required to use the SWIM models. Brian, next. For the city, the Lower Southern Rivers model, which is the lower part of the city, we did that in the Mike suite of models. The reason we did that is the Lower Southern Rivers doesn't actually experience a diurnal tide. The nearest connection to the ocean from the Back Bay and the North Landing River is about 90 miles south at Oregon Inlet. But what does occur in Back Bay and the North Landing River are wind tides, where the wind will blow from the south for 3 to 5 days at a strong clip, and it will raise the water in those water bodies about 1.5 feet. So by using the Mike program, we were actually able to include the effects of that wind in the modeling to be able to establish where we have flooding problems and where we need to make improvements is what we're working on at this point in time. For the rest of the city, we've used the PC Swim software. We've intentionally picked the PC Swim software because it's 100% compatible with EPA Swim. That was important to us because we don't want to require any engineer to have to go out and buy a program. Every model that we have will run in EPA SWIM. Even the models where we've done two-dimensional modeling will run in the EPA SWIM program. We use PC SWIM only because it has a better graphic interface, and it also allows you to be able to input the GIS information directly into the model. Brian, next. To give you a comparison, the last time our models was done, it was in 1990. What you see on the left is the Thalia Creek drainage basin, and in that model was 46 nodes and 58 conduits. The current model has almost 3,200 nodes, almost 14,000 conduits. We've managed to model everything from a 24-inch, Brian, I'm sorry, next. We have modeled all the pipes 24 inches in diameter. We've modeled all our stormwater management facilities, all our natural conveyances, the canals, the ditches, the swales that help get the water to the tidal bodies. We modeled the 1, 2, 10, 25, 50, and 100-year storm events. We did model the 500-year event, but we don't design to that. That was really just done to provide some hazardous information for the sea level rise benefit cost analysis. We have prepared the models with 1.5 foot and 3 foot of sea level rise. But as we like to tell people, anybody can build a stormwater model. The question is, how do you prove its accuracy? So we did validate and calibrate our models to known storm events. Some of the pictures you see there were actually provided to us by residents during Hurricane Matthew. And I'm just going to use the one with the mailbox. You can see the water's up to the bottom of the mailbox. So we had our survey crew go out and shoot the elevation of the bottom of the mailbox. We know what time the picture was taken, what date the picture was taken. So we actually can look in the model and see what elevation in the model is the water rising to at that point in time. And on average, our models are calibrating to within 1/2 inch of what is shown in the pictures that you see. Brian? From a rainfall standpoint, we've implemented what Brian talked about a 20% increase. As Brian mentioned, right now we're experiencing about 10% more than what NOAA Atlas 14 shows. But we decided we wanted to build resiliency in. So we decided we would increase that by 20%. And we are actually in the process right now of updating all of our models to incorporate the standards that were adopted 2 weeks ago. Brian? From a sea level rise standpoint, the Public Works Design Standard Manual will require every project to account for sea level rise. If you're determined to be non-critical infrastructure, you will have to design your site for 1.5 feet of sea level rise. If you're critical infrastructure as defined by the city's Office of Emergency Management, then you will have to design for 3 foot of sea level rise. So evacuation routes, hospitals, fire stations, evacuation centers, those will all be designed to account for 3 foot of sea level rise to make sure that as you get towards 2085, we don't experience flooding at those facilities. Brian? One of the things that was difficult to get the public to understand, in particular the design and development community, was there's a cost. We understand there's a cost for requiring this additional design for new projects, but as our Hampton Roads Planning District Commission, which is 17 municipalities in this area, the working group stated, adopting higher standards will be more expensive, but keeping the same standards increases risk. So either way, there's a cost. So you can either adopt the standards and you put part of that cost onto the developments that are occurring, or you don't adopt standards and that risk becomes the responsibility of the city as you move forward. As part of Matthew, in Julia, we had a neighborhood that was only 10 years old that flooded because an incorrect tailwater was used. The actual modeling was not done to a certain standard. So we want to make sure that doesn't happen again as we move forward in the future. Brian? And that's actually, got done early. This has never happened to me. So I will say that Brian and I do want to say thank you to NOAA for their assistance that they provided to us for this project. We very much appreciate their time and effort. Part of their requirement was that we shared this information with other municipalities, with other localities. We've done that with every one of our neighboring properties, neighboring municipalities. We've done that with all of the DoD facilities that are within the city and in adjoining municipalities. We've gone down into North Carolina, to the northeastern parts of North Carolina, and shared that with them. And even though the requirements of our NOAA grant are over as of March 31st, we still want to provide any information we can to anyone else, and we'll be available for questions later.
Wow. Oh, sorry. I'm so amazed. Emily, I'll let you do it, though. I couldn't help exclaiming my own surprise at how fast that went.
No, but thank you so much, CJ and Brian. And a couple more questions came in for you in the chat box. So if you want to respond to those in the chat, or we can wait until the
I can address those
end.
now if that's,
we can
since
address
we have
those
4 more minutes.
near the end when we have it. Sure.
Okay.
So the first question is from Abby Sullivan. So is the Public Works Design Manual publicly available, or will it be?
Yes, it is, and I will grab that a link and put that into the chat here in the next couple minutes as to where that can be found at.
Excellent. Thanks, CJ. And then from Amy Eason, did you use the 2D features in PC Swim or 1D?
Majority of the models are prepared in 2D, but we do have some areas, 4 different areas within the city that we've done 2-dimensional modeling because the elevations range maybe a ½ foot over the entire neighborhood. So you're talking about, for example, the Windsor Woods neighborhood is anywhere between an elevation of 4.5 and 5.5. So you want to be able to, in that case, put the 2-dimensional modeling in to allow that water to be able to flow the actual directions it would across the land when your boundary condition is at 5.5, which is what it was during Matthew.
Great. These are excellent questions. So please keep coming in with the questions as we go. Another question from Tina Hodges. How did you determine the design should be 20% above Atlas 14? How would you respond to hydraulic engineers who say you shouldn't just increase by a certain percentage, but use data specific to each site?
What we did is actually looked at the and Brian will correct me if I'm wrong with this because we have that type of relationship. We looked at RCP 4.5 and 8.5 and projected those increases out to the year 2085, which is the 50-year time frame we were looking at, and it was showing a 20% increase on average. So that's why we increased it. So we do have science behind us.
Yeah, and one thing, CJ, I think it might be important too to mention that even within the Atlas 14, the rainfall amounts across the city are not that different. If that's correct. That you use correct. Like one number for the whole city, so we applied it to that one number. And the recommendation was based on many lines of evidence from the historical trend to the future trend and some other pieces. Yeah.
Great. Another question from Chris Zambito. Will you be able to leverage some of the CRS credits for higher standards to offset some of the cost impacts?
We are actually in the process right now. Our floodplain manager for the city is looking at how to obtain those CRS credits by having higher standards. We currently are and I'm looking to my friend Sue because she's more up on this than I am. We are currently level 7 in the CRS program. With the higher standards and a few other things that we've done, we anticipate sometime next year we'll probably be at level 6.
Great. Thanks, CJ. Another question from Christina Hudson. Hi, Christina. Are the sea level rise projections to be used alone or in concert with the 1% annual chance event flood elevation? Evacuation routes would be relevant during a storm event, so it seems to make sense to add sea level rise projections to the 1% ACE.
Okay. What we require is based on the size of your project, you have a design storm that you have to use. Anything less than 300 acres, which is probably 99.999% of the projects in Virginia Beach now, will use a 10-year storm event, which is a 10% chance storm. But we do require that the 100-year storm be checked to make sure you're not increasing flooding downstream or upstream. And that is both in the base condition and with a 1.5 feet of sea level rise or 3 feet of sea level rise, depending on if you're considered critical or not.
And CJ, I would just add that I know with several other roads within the city, there's certain like levels of design for coastal flooding, and you know, if it was the 1% annual chance coastal flood event, the sea level rise would be added to that as well to determine a design flood elevation for that project. And we did apply the sea level rise scenarios to a host of coastal flood conditions, from nuisance flooding, daily tidal flooding, to the 500-year type flood. So all that information was part of the study.
Great. Well, there are a lot more other questions coming in, but we'll have to hold off on those because we need to transition over to Florida. But thank you so much, CJ and Brian. It's clear that there's been so much work put into this effort, and the fact that all the models are publicly available for people to use is excellent. So thank you so much for your work on this. And now I'd like to transition over to Jennifer Hirado, who is the Chief Resilience Officer and Division Director of Broward County. She'll be sharing with us how Broward County advances a progressive and adaptive approach to preparing for climate impacts. Dr. Jennifer Hirado is responsible for leading the county's climate resilience initiatives and environmental programs focused on policy, planning, and management. Since joining the county in 2002, Jennifer has been a key figure in the coordinated advancement of multi-jurisdictional initiatives, with a focus on sea level rise adaptation efforts, alternative water supply projects, and conservation programs. Current priorities involve the establishment of future conditions, plans, economic risk assessments, and creation of county-wide resilience and infrastructure improvement plan. She has been a participant and leader in the Southeast Florida Regional Climate Compact since its formation in 2009, and has been a primary contributor to water management and economic resilience focal areas. She currently serves with me on the board of directors of the American Society of Adaptation Professionals and on the board of the American Geophysical Union's Thriving Earth Exchange. Jennifer, take it away.
Okay, well, Emily, thank you, and thanks to Beth for putting together the series. And as I had shared when we were setting things up, I was really excited to be able to present in conjunction with Virginia Beach and the partnership with Dewberry, and see a lot of kind of synergies between our work, but I think it's really impressive to see the level of detail which they've been operating. I'll be talking more about our work as partners in the regional effort of the Compact, and share how some of that regional initiative has aided the effort specific to Broward County. And then I'm going to kind of circle back and talk about how, once again, working at the regional level ultimately serves to aid in implementation. So it's kind of been this, the regional initiative kind of bookending things in terms of helping to set up and then aid with implementation. So the next slide, please, Beth. Just as a little bit of context, I think we all know where Southeast Florida is, but Broward County is just north of Miami-Dade. We have a population of about 2 million. Our region as a whole has a population closer to 6. We're all very flat and low-lying, and quite a bit of dense coastal development, so we share a lot in the way of exposure. So you can see in the 4-county area, which makes up the compact, that we're kind of squeezed into a relatively small geographic area, and that's provided a lot of impetus for ultimately our working regionally. We share a lot in the way of exposures that I think are all kind of familiar to folks, but I'm going to be talking mostly about flooding and adaptation planning today, but I wouldn't want to negate the importance of all these other challenges in our region. Next slide, please. And so just again, for some context for those who may not be familiar, the 4 counties recognizing these exposures did come together in 2009. Prior to that, we've been working with individual sea level rise projections, individual mitigation strategies, oftentimes calling upon the same experts, but developing quite a bit in the way of varied guidance. And so our leadership acknowledged that we had a lot to gain by developing shared tools. Ultimately, we wanted to be able to harness the strength of our numbers in the region and hopefully gain more in the way of investment that could collectively advance our planning. And we knew that we also had a lot of interdependencies, whether we were looking at issues of water supply or our shoreline management strategies or transportation systems. And we knew too that we had a very connected community as it related to economics and where we work and live. It's really just one quite large kind of metropolis. So with the formalization of our compact in early 2010, we've worked in collaboration since that time, organized on the primary elements of policy coordination, developing a shared baseline for planning, developing and working collaboratively on implementing a regional action plan that does not supplant local efforts, but serves to provide us a framework for compatible initiatives. And then we convene annually to host and advance our efforts through, or host summits and advance our efforts through kind of like a new action plan. Next slide, please. So some of the major areas of concern that we've taken up over time, and specific to my local efforts, have focused on the issue of planning for the combined impacts of rising seas and increased rainfall. And for some time, we've known that much of our adaptation will be influenced by how we are shaped by water, as we have historically been, and how we choose to manage water moving forward. And there's many diverse ways in which this will need to be addressed as we look at our planning and investment strategies, including land use, drainage, design standards for infrastructure, finished floor elevations, where we choose to put infrastructure. And prior to coming together with kind of the common guidance and having something formally implemented, we were seeing a lot in the way of individual investments, but these were kind of one-off projects. Sometimes the adjustments were made in the course of a development project. You know, they'd be out there with bulldozers and cranes sitting in tidal flooding water, and then, you know, hurriedly, you know, trying to reinforce the seawall. So we know that there's a dramatic need to see coordinated investments and also have synergies and you know, work to identify and maximize synergies through these combined infrastructure improvements. The next slide, please. So one of the early deliverables coming from the Southeast Florida Compact was the development of a sea level rise projection. You're actually looking here at what was our second iteration to this curve, but I reference it here because so much of the work that's taken place to date was based upon this curve developed and adopted in 2015. At the time, we were collectively organized around planning for the Army Corps high curve, and based upon a 50-year planning horizon from 2010 to 2060, anticipating about 2 feet of sea level rise. And so over, as I said, over the next several years, we began to work diligently on how to formalize the integration of that curve into our planning efforts. So I'll talk a bit about how this advanced in Broward County now. We began with adopting within our land use plan and within our comprehensive plan itself, priority planning area. This was in advance of some of the more complex hydrologic models that we would be able to amend to look at the impacts of rising seas, but simply based upon elevation and predicted levels of increased risk, we were able to delineate those areas. And now when we had proposed changes in land use, they'd be subject to an additional level of review for resilience requirements by, again, falling into this area. We've also adopted this map as part of the county zone capital planning requirement. So any projects for which there are capital plans that fall into these areas must too address sea level rise considerations. Next slide, please. That was just, again, the first kind of tool that we were able to move forward with immediately in advance of more complex modeling. At the same time, we were working with the United States Geological Survey to identify or quantify the effect of rising sea on the groundwater table, knowing full well that we were seeing a lot of sluggish operations with respect to drainage systems, drainage wells, dry retention in areas were perpetually wet. We had had a recent county investment where the dry retention was wet. We were seeing groundwater monitoring wells that were revealing water elevations a foot higher than what was established in previous maps. So in working with the USGS, modeling that impact, the image shown here in the center shows the red areas with the one-to-one response and that change of groundwater table in response to sea level. The cross-section on the bottom right shows the historic groundwater table used for license setting, design requirements for drainage and stormwater systems is that dashed line. The dark solid blue line is the remodeled groundwater elevation with 2 feet of sea level rise. Brown line indicates the land elevation, and so you can see in the west-east cross section the amount of change that was predicted in the eastern areas, and where the blue and brown lines intercept or begin to converge, that's where we have the more significant drainage challenges, would alter the way in which we have to look at site development. Next slide, please. And we also counted for an increase in annual wet season rainfall in that analysis. So that was one of the early investments, because we were already, I'd say 10 years ago, seeing those implications. And so we were able to move forward with that fairly quickly. We also began work to identify a common resilience standard for what we call tidal elevations, but really seawalls, berms, coastal infrastructure, marina designs, anything that could serve as an avenue for tidal water moving into the urban environment. We worked here with the Army Corps of Engineers. Taylor Engineering had performed the modeling to assess the predicted coastal water elevations with the combined impacts of the 2 feet of sea level rise, high tides, and high frequency storm surge. And with that work, we were able to advance a recommendation for adjusting our, or not just adjusting, it was really establishing a countywide standard. We had previously no countywide standard. Many communities had maximum limits, but few minimum requirements. And so this was going to be a major advancement. The study itself took several years, 2 years. We spent about a year on public outreach, and then just early this calendar year, we were able to amend our land use plan and the county code of ordinances, establishing this new standard requiring an elevation of 5 foot NAVD by 2050, and allowing cities the discretion to permit at 4 feet NAVD up until 2035. I just want to be clear that it doesn't require seawalls as a solution. Living shorelines and berms and other strategies are acceptable and encouraged, but clearly we have a lot of seawalls in Broward County, especially nearly 300 miles. So we do appreciate the application to seawalls. The next slide, please. So this was a major step forward in terms of thinking about maximizing the extent to which we prevent water from entering the urban environment. But we also know we're seeing changes in our flood levels. And we have used a variety of tools over the years for setting finished floor elevations. We've tried to stay ahead of the FEMA flood maps. We've maintained something called a community flood map that has been forward thinking. It looked at our community at build out and anticipated flood elevations under those conditions. But with the years and the remodeling of the FEMA flood maps, we began to see those converge. So we undertook a study to incorporate the combined impacts of rising seas on groundwater tables, water management systems, and flood elevations to try and keep ahead of those maps. We know it's important not only for reducing risk, but there are dramatic implications for insurance rates and as well insurance rate reductions that can be achieved through these more stringent standards that we implement locally. The next slide, please. So this was a fairly elaborate process, and we are still in the midst of this. I just want to acknowledge that we too use Mike series model for our flood elevation work. It's in fact the county's Mike 11 model that was used by FEMA in the most recent FEMA flood map update. And so the work that we were undertaking now would use this same model that was already being employed for setting insurance rates to improve the model detail, improve the resolution. A lot of other enhancements were made with regards to surface storage, infiltration rates, etc. But we also brought into this model then the change in the groundwater table and amended the rainfall projections and incorporated the 2-foot sea level rise scenario and limitations on discharge results. A lot of stakeholder involvement in the process, as well as financial cost share in the model study itself. Next slide, please. I won't get into too heavy of details, but I want to note that the addressing of precipitation was a major task in this analysis. And we know that the global models certainly, and even the downscaled models, have not performed particularly well or demonstrated consistency in terms of the representation of rainfall projections and trends under varied climate conditions. We brought together under this contract, Geosyntec was the prime on the project, Taylor performed the engineering, but Clim Systems and Jupiter were contracted to support this particular task, and we had a expert kind of peer review panel that was aiding us, involving representation from the USGS, our South Florida Water Management District, and FIU. And the exercise, and we have, again, the technical report available, but evaluated a variety of downscaling techniques and, of course, corrections for bias, and looked at both our 24-hour and 3-day storms to identify change factors similar to that which Dewberry had shared in terms of adjusting our precipitation trends within this model and modeling the 100-year event. Next slide, please. Here, I'm not going to belabor, but what was demonstrated here, that with all the varied techniques, all of the analyses consistently showed a predicted increase in the intensity of rainfall events, and here the focus being on 24-hour and 3-day events. Next slide, please. We then too found that looking across Broward County, there was not sufficient variability across the rainfall stations to justify individual change factors, so we too ended up with a single change factor for urban Broward County. Next slide, please. And the peer review panel also agreed on an evaluation involving a super ensemble approach. So we looked at a super ensemble for the models and then teased out the statistical and downscale and dynamic downscaling strategies. You can see the data here. It's available in the slides, but I'll just go to the next slide, please. The long and short of this analysis was that we settled in on a 13% change factor for the 100-year 3-day storm event. This was supported by the super ensemble, and for the 24-hour rainfall event, we leaned towards or utilized, I believe it was the statistical downscaling, and settled on a 20% change factor for those events. Next slide, please. And we found that was a result of some consistent negative bias that was found in we settled with the dynamic downscaling in lieu of the statistical for the 24-hour. We did not model all of the individual lesser storm events, but anticipate applying the 20% across events of 24 hours and less. And we felt that these results, not only were they deemed reasonable by the stakeholder group, but we felt that the Dewberry study also helped to validate the reasonableness of the 20% for the higher frequency events. Next slide, please. All right, here we're now moving into what is the midst of our process. So shown in this graphic is, and we do use other tools, but this is a interim work product. The FEMA 2014 flood map is obviously shown on the left, and on the right are the results from the model output showing the changes in the extent and depth of the flood elevation under the combined impacts of the 2-foot sea level rise combined with the October or king tide and those reductions on our discharge capabilities combined with the 13% increase in the rainfall intensity. We are still in the process of reviewing additional model output, but this provides fairly good insight as to where we expect to be with our final establishment of our updated community flood map, which again would be used for deciding finished floor elevations and guiding critical infrastructure. Next slide, please. The next stage now, while we're wrapping up that modeling, we also have to acknowledge that we've just adopted an updated sea level rise projection, also produced by the compact, and that brings us now to a 40-inch planning horizon. So just noting here that the work is never done. We're going back to the priority planning area maps. We're in the midst of public process on updating that map to account for the 3.3 feet as opposed to the 2 feet that was adopted based on the 2012 evaluation. Next slide, please. We're also in the process of updating the groundwater table map with the USGS to accommodate the 40 inches and its influence on storage in the soils. And we're now planning to bring all of that work into the development of a countywide risk assessment and resilient infrastructure plan that will look at water management needs, distributed storage, combined infrastructure and development strategies. Next slide, please. And that will be conducted on a sub-basin basis. Kind of the final note here is that heavy in this evaluation is the quantification, the valuation of the risk reduction in terms of measures that are appreciated by risk rating entities, that are relevant to bond rating entities in the insurance market, and frankly, investment strategies. And so we'll be working to incorporate in that evaluation a full kind of return on investment that comes through a combined and sustained infrastructure investment plan that addresses this future condition risk. It's heavily supported by collaboration with the private sector here, not only in Broward County, but across the region. Similar to what was shared by Virginia Beach, economic resilience is a key part of our strategy, and being able to speak about the return on investment that comes through proactive investment rather than the costs that come to a community later. And the next slide, this is further reinforced by a study that's just being submitted to our grant partner, Florida DEP, Department of Environmental Protection, where we as a region have provided collective cost share in developing a business case for resilience with economic modeling provided by AECOM utilizing the REMI model. And it's very much focused on the ROI that comes through systemic investments in adaptation as well as building level results. I'll note that for Broward County, the evaluation was about a 2-to-1 return on investment. It was even higher for Miami-Dade County. I won't go into the details as that deliverables just being submitted today, but I hope that that evaluation too ends up being valuable to others. And the final slide, just a quick summary noting that clearly our strategies are constantly in motion. We're always having to provide update and revisit, the projections based upon evolving science, and that's part of what we communicate in the region. Many partners and partnerships have been critical to the progress that we've made here, but I would note the most accelerated action has maybe come during the last 2 to 3 years in our working with the private sector and the revised framing on economic resilience. Next steps will certainly involve that whole community plan that we're providing the foundation for, continued economic strategies that involve private sector partners, and improve communications that resonate with all members of our community. And we continue to have to make progress in that area. So with that, I'll conclude. And as I said, I appreciate the opportunity to share. Thank you.
Thank you so much, Jennifer. And it's amazing to see all the progress that you've made within Broward County and the dedication that you all have to continue to evolve and adapt climate resilience planning. There were a couple of questions related to your talk. If you want to address those in the chat box, Jennifer, or we can bring those to the questions at the end. But we're going to change now to hear from 2 of our colleagues. We're going to have some brief reactions on these 2 presentations and hopefully gain some inspiration on how innovations like these in Virginia Beach and Broward County can be replicated across the country. So joining our discussions are Ruwanka Persaga and Beth Gibbons. Ruwanka is a civil engineer for the Los Angeles Department of Water and Power and serves on ASCE's Committee on America's Infrastructure. Through his roles in ASCE, Ruwanka has worked on the 2019 California Infrastructure Report Card and is part of the planning committee for the 2021 ASCE National Infrastructure Report Card. Ruwanka is also a member of the ASCE Engineering Practice Policy Committee and is currently the president-elect for the ASCE Metropolitan Los Angeles branch. Outside of work in ASCE, Ruwanka founded a 501(c) nonprofit called Kicks for Kids and is a Big Brother mentor for the Big Brothers, Big Sisters of Greater Los Angeles. For Ruwanka's efforts in the engineering and LA community, Ruwanka has been featured on NBC Learn and Time for Kids. Beth Gibbons is the executive director of ASAP. She's responsible for strengthening the capacities of individual adaptation professionals, adaptation and resilience-oriented organizations, and accelerating the evolution of the adaptation field of practice. Prior to joining ASAP, Beth directed the University of Michigan's Climate Center and managed NOAA's Great Lakes Regional Integrated Sciences and Assessment Center. She has over a decade of experience in development in the US and abroad. Beth served in the Peace Corps in Togo, West Africa, and holds a Master of Urban Planning from the University of Michigan. So Ruwanka and Beth, give us your thoughts.
Thanks, Emily.
Beth, did you want to go first, or?
No, why don't you kick us off?
Okay.
I mean, I just thought that was a blast to learn so much, so I can't wait to hear your reactions to it.
Yeah, my name is Ruwanka Persaga, civil engineer for LADWP, member of the American Society of Civil Engineers, or simply ASCE. I did want to thank the Virginia Beach and Broward County project teams for their excellent and informative presentations. As Emily mentioned, I'm on ASCE's Committee on America's Infrastructure, which is a group of over 30 civil engineers who volunteer to provide our expertise on infrastructure topics. And we work with the ASCE staff to prepare the National Infrastructure Report Card, which a lot of you probably know about, and is set to release in February of next year. As a committee, we assess all relevant data and reports. We consult with technical and industry experts like yourself, and eventually assign grades through an easy-to-follow A through F grading system, which will also provide recommendations for how to improve those grades. Looking at my notes for these both presentations, I saw things like policy to reduce short and long-term impacts, a fine-tuned public outreach process to advance resilient initiatives, and communications that resonate. And I think those tie in with the report card so well, because the report card is a vehicle that to have these conversations and further push these initiatives. The report card is an advocacy tool meant to be approachable, easy to consume, and you don't need an engineering degree to understand it. And with resiliency and climate change, it's brought up in every single category of infrastructure. And then I did want to highlight, I thought it was really cool, the quote at the end of Virginia Beach's presentation was, adopting higher standards will be more expensive, but keeping the same standards will increase risk. I couldn't agree more with this. I thought it was really good to add that at the end. It also ties into an ASCE reports the failure to act report, which some of you might be aware of, which researches and presents data related to the investment gap, which is basically for every dollar we aren't spending today, it's costing us triple that amount down the road. But besides the cost, there's a risk associated with not updating our standards to today's needs. And as technical professionals, it's our duty to make sure we're always self-analyzing our methods and standards and then providing those recommendations for updates, which today's presentation's covered. I guess I'll add just lastly that the failure to act report, there's a new one coming out in October of this year, so definitely keep an eye out for that. The ASCE National Report Card and the failure to act, those are really critical tools that we can all use when we're looking at community outreach and we're looking at starting discussion on all of these items. So just wanted to end out with that.
That's awesome. As we've talked about before, Ruwanka, I love the report card. I talk about it all the time. I think it's a really critical tool for how we bridge between adaptation and resilience when we think about the infrastructure deficit that we have here. But in thinking about these projects, as I was kind of laying my thoughts out, I was thinking to myself, like, what do I love about these projects? What do I see as replicable? And what do I want to see as the next step? So like, what's the pathways forward? And just a little bit on what I love in these projects. I think in both cases, they really speak to a comprehensive nature of thinking about sea level rise, of thinking about the design storm, of thinking about the community, and really thinking about multiple medias for being able to distribute that message from sea level wise, which I think is great. I love it. The sea level wise story map, which Virginia Beach has released, is one of the best story maps that I've seen out there. I think it really does a great job of bringing to life the work that the city has done in a way that's extremely accessible for people who just want to be able to kind of see this in pictures and get a sense of what does this mean for me, or what does this mean for a community that may be like mine. When I look at what's happening in Broward, I think there you see this amazing story of what regional governance can do for a municipality and for really moving things progressively forward and continually over time. And I loved how Jennifer talked about, the beginning of that, the priority area planning from 2012, and now we're coming back to that priority area planning again, because this work is really iterative, it's adaptive. And it means that you're not just putting a stake in the ground and leaving it there and saying, that's what we know, we're not going to return. Like, we're really thinking about building flexible systems that we can return to and iterate on and continue evolving our knowledge about. And think about replication. I think that it's awesome that both of these projects are using the EPA tools, they're using the SWIM models, they're using resources that are out there that are accessible for all communities to dig into. I think that there's a really interesting replication story that I would love to see explored around that 20% change factor. I mean, there's obviously a question that myself as a total neophyte asks that says, if Broward County is seeing a 20% change factor and Virginia Beach is seeing a 20% change factor, man, I'd really love to see what, Charleston is seeing. And I'd like to see a couple other coastal communities play this out. And saying that, those IDF curves don't actually need to be renegotiated across multiple points in a municipality or locality. We really have pretty consistent application of a curve across a large area. And I think that both communities were able to speak to that. And I love that. And I really do challenge another community that's on the Eastern Seaboard to come forward and say, would we see a similar change factor? Because if so, we can start really cutting down costs by starting to just share this information and look for replication. And so I think, to me, that's kind of where we talk about what are the next steps. And I look to ASCE and I see, an organization that obviously is so well established, has an amazing group of young professionals who are coming forward, who are thinking about resilience. And so I wonder, what do you hope that you see at ASCE in bringing this kind of replication for thinking about resilience and adaptation into your profession with you and your colleagues?
So I know ASCE on a national level, we have a resilience committee. I've actually helped with some of their annual events here in California. And it's growing. I've seen resiliency when I go to conferences, when I go to different webinars and such. It's something that's always being brought up now that wasn't being brought up 2-3 years ago. Yeah. So I love that. And the way I define resiliency is, how are we able to respond to an event? It could be sea level rise, it could be an earthquake here in Southern California. And it's just our ability to, as infrastructure advocates, to make sure that our communities are prepared and make sure that everyone's aware of how important this is. What I want to see is, just the continued discussion about resiliency and then how broad it is. It's so broad, it covers so many different topics. For me personally, I think that's really where we want to see this continued discussion. I'm glad we're able to have this right now.
Yeah, and I know that there's a lot of technical questions that people want to kind of get to from our 2 case studies, but I just want to highlight that as of today, the House Select Committee on the Climate Crisis did drop their recommendations for climate and resilience, and I think that there's a lot in there for ASCE, for ASAP, and for other people to take a look at, to start thinking about. With this body of recommendations that's now being put forth to Congress, we're in a moment to really think about how do we want to drive forward a recovery that's going to be resilient, that's going to be just. And I think that there's a window of opportunity that is opening, and we should really be prepared through our societies and our practices to walk through it.
And I could listen to you guys all day, and I know that we want to get to a panel discussion, but thank you so much, Beth and Rawanka, for your thoughts. And I think we're going to move into the panel discussion. And so I'm going to begin with questions that I have about the work that we've heard about today, but we will also be addressing some of the questions that are coming in. They're excellent questions, so thank you for participating and being active in this discussion. So first question for the panelists. What has made the relationship between consulting firms and municipalities so successful and productive? And if folks want to turn their videos on again, I think that would be great as well.
Well, Emily, I don't have a video, but this is CJ from Virginia Beach. What I will say is from our standpoint, we always try to make our consultant firms part of our team. You know, a lot of times you see when you have a consultant, they give you exactly what you want and that's it. What we found with Dewberry is Dewberry would come forward with questions that are important. They're questions that we were getting from our citizens, and we would work forward to getting answers on that. We never considered them to actually be a consultant. We considered them to be an extension of our team. It's to the point that I've been with the city for 5 years, and the city has never renewed someone's annual services contract without it going back out to bid. Dewberry has done such a fantastic job with us. They are the first ones to actually have their annual services contract extended as a sole source because they are such an integral part of our team.
That's excellent. Thanks, CJ.
I would just say the same here for the partners that work with us in Broward County, and especially on long-term and sustained projects. Sometimes the consultant partners are more consistent than our staff members. So that partnership and the trust and the technical competency and that history of the relationship, I think goes a long way. I mean, clearly, you know, we have a competitive process and some projects don't lend for that same level of sustained engagement, but I think that we've found our consultant team generally to be, you know, very accommodating and, you know, really trying to find workarounds where we've run into, you know, challenges with the, you know, the initial scope. Oftentimes, you know, you just don't really know how things are going to, you know, proceed. And so they're bringing their technical, you know, competence to alternatives in the course of the project, and being willing to see those through goes a long way to helping to ensure that we get the work products that we need.
Great. Brian, anything to add?
I think Jennifer summed up some of the pieces really well right there, and that a lot of this type of work, when we scope it and we work with folks like Virginia Beach, it's really complicated. And we learn so much as we go through it. And, you know, in this case, you know, we were offered a lot of flexibility, and, you know, we worked within that to try to understand things and learn from them and keep it going. And I think, you know, for these kind of scopes, when you're looking at such complex things, it's a critical thing to have that flexibility and have folks that understand that with a lot of these different aspects that, you know, these coastal communities are faced with right now. There's no book written, there's few papers written. It's a lot to figure out, and it takes a lot of thought and flexibility to get there.
Great. Yeah, and the true partnership, I think, between municipalities, consultants, and other partners, testament to the fact that there are so many different people to manage this challenge. Thank you for that. I'm going to actually pepper in one question that Ned Gardner had posed, and he said, are the speakers' peers learning from and applying what they're learning? And are engineers considering legal liabilities associated with not designing for climate change?
I'm going to, from a Virginia Beach standpoint, we found that our peers are listening. My supervisor, Tony Utterback, and I went to DC and did a presentation at the RAND Corporation sponsored by NOAA. And out of that,
uh-oh.
How about that?
Yeah,
we lost CJ.
Okay. So we went to the RAND Corporation back in March for a presentation sponsored by NOAA, and out of that, the Water Utility Climate Alliance has asked us to come do a presentation to them next month, as New York City and Philadelphia and Phoenix and San Francisco all wanting to see what we're doing so that they can, I would like to say, hopefully emulate what we're doing. But we do find our peers are doing that. I'm going to leave the legal liability question to Rwanda, because I'm not an attorney, and he probably has a better idea from an ASCE standpoint of legal liabilities of ignoring things. I hope.
One thing I would add, just for the peers and stuff picking it up, and this is just an example of how things can progress and get propagated from one study to another, is as Virginia Beach took these kind of standards up to their regional planning district commission to kind of socialize that and have the region consider it, a question came up about, you know, whether the Virginia Department of Transportation, if a project would be designed to this, would they go along with that or not? And so we leveraged some of our client relationships through our transportation practice to have a meeting with some of the folks that direct their scientific team for VDOT, and they ended up listening very hard and doing their own study, which fortunately validated the values that we had, but also now they're considering that for their climate design guidelines, and it's also a standard that the state is considering that it might come out as part of the coastal master plan that ends up for the state of Virginia. And just talking to some folks from the state, I know that they have been working with nearby states such as Maryland, et cetera, to gather up a coalition to ask NOAA to update the Atlas 14. So it's great to see efforts like this snowball out. I mean, it's one of the best outcomes you could wish for when you do this kind of work.
Mm-hmm.
I guess I can quickly just mention, designing for climate change is, it's in the codes, it's in the standards, it's what, these two projects did, is implementing it in our standards and codes. So it takes a huge effort for everyone to look at what they're doing and ask the question of how does climate change affect what I'm working on, and how can I implement that in my design? The way legally it would come up is obviously standards and codes, and I've seen it in type of building material you would use to like resilience design. As far as legally not designing for climate change, again, it would go to the standards and codes. So if you're not following the building code, which includes climate change adaptation in it, then you wouldn't be legally following the code. I don't know if there's anything further than that, but it's an interesting question.
Yeah, absolutely. And Beth, you mentioned Charleston in your remarks, and Sarah Watson says that Charleston starting tomorrow will be using a 20% increase based on the NOAA 2515 probabilities, very similar to what Virginia Beach is using. Their stormwater manual is here. So thank you for sharing that, Sarah. On to another question that I have. So what is one transferable lesson that every community or a community like yours could adopt?
I'll just share that in the work here in Broward County, you know, part of the process did involve moving into the regulatory environment with changes in the design standards and licensing. And in the course of that, we had heard that we were probably going to find some resistance. And very key to the success in, say, the future conditions drainage requirements was our ability to evaluate a variety of development projects that had been recently licensed in our community and how those would be amended or modified under the amended requirements. And then we were able to work through the delta on cost associated with that resilient design. Of course, we worked with you know, our engineers and another, you know, a variety of people to do that. And we were able to show that the delta was only 0.6 to 1.6% of the projects that we looked at. And in the end, we presented the information and we found no objections. It's been really important for us to be able to talk about economics in the conversation. And the new requirements are not, you know, I think that they're significant enough that they do cause folks to pause. But when we're able to speak about exposures that come absent that, as we did on the seawall evaluation, we had an economic component. We worked with RMS on that. Ultimately, we found no objections in that process. We've had tough conversations talking about the 20% delta on the rainfall scenarios. But despite the challenges, you know, what's the option? So our ability to talk about economics has gone a long way to building support within the private sector. And that endorsement has been fundamental to, I think, building support through the engineering and development community that clearly has to be a partner, because that's where a lot of that investment is coming from. So I think being able to speak with some capability in that regard is vital, and being able to have frank conversations and a partnership with the private sector, I think it's been a game changer down here to have that collaboration.
Thanks, Jennifer. CJ or Brian, any thoughts on that?
One, in Virginia Beach, I'm going to give you two quick, easy ones. One is you need to know where you're at in order to know where you want to go. When we originally started this process with our master plan modeling, we were missing probably about 40% information on the pipes within the city of Virginia Beach. So it's kind of hard to do a model if you don't know what the inverts and the size of the pipes are. And when you have pipe that would stretch from Virginia Beach to Denver, that's a whole lot of pipe to be missing information on. So you got to know where you're at in order to know where you want to go. But more importantly is, don't be scared to go talk to the public. When we started out this process 5 years ago, we were called all types of things about, we didn't know what we were talking about, and we didn't know this, and we didn't know that. And now we actually have civic leagues and environmental groups that are standing up to council members saying they know what they're talking about. They know what they're doing. But you don't get that if you don't go talk to the public. If you don't let them know what you know and hear what their concerns are, you're fighting an uphill battle that you're not going to win.
Yeah, absolutely. And, you know, something that's obviously been on the forefront of people's minds lately and really reflects your comment, CJ, this question of values of justice, inclusion, and diversity as we move forward with these projects and true implementation. And how has that been a part of your work to date? And how to, you know, are there any ideas on how to incorporate that or continue to incorporate forward?
From our standpoint, the city has a set of standards regarding inclusion and diversity. We follow those standards. As part of our sea level wise analysis, we had Dewberry do a social vulnerability analysis to see if we have portions of the population that are more vulnerable in some locations than they are in others. If you look at things strictly from a benefit cost ratio, some of those more socially vulnerable areas are not going to rank out very high, but they're just as important to us as city staff and to the citizens as they are to save the multi-million-dollar homes that are on the ocean front.
The issues of migration within the region are a real challenge, and we've had some excellent work that's been shared regarding evaluation of likely migration trends based upon elevations and levels of risk and finance. As we move forward, I think we have a dramatic responsibility to provide the infrastructure investments that allow folks where water levels can be managed to continue to reside. The financial implications of having to relocate, even if it were an option within our community, are quite grave, especially given, trying to, well, housing is a major issue anyway. We rank very low in the nation with regards to affordability, and the cost of relocation here is doubly difficult for looking at where you've maybe had a longer residence. That information, issues of flood insurance costs, will be prominent in the risk assessment that we'll be undertaking, and really being thoughtful about how we can support the communities, and also look at redevelopment strategies where absolutely we need to move people out of vulnerable areas because it's just going to be wet beyond 3 feet. We won't be able to manage. We'll need to find thoughtful ways about how we couple those changes in land use with housing needs and relocation that can keep people within our community in an affordable manner. We're also very concerned about the personal costs that come with personal resilience. Clearly, issues of seawalls are one. And we do not have a good finance strategy or option yet for a lot of that. PACE is one form of personal financing for some resilient improvements, but really not on the flood side. So we're going to continue to struggle in that area and look for private sector participation as well, and not-for-profits to help aid in identifying mechanisms that can provide some support. But we have a lot of work to do.
Great. Well, thank you so much. This has been a fascinating panel, and I knew that time was going to fly by, and we are nearly at the end of our session. So as we start to wind down, we have a couple of poll questions for the audience joining us via Zoom, and then I believe Beth has some more information to share about upcoming webinars in this new series.
That is right, Emily. Thank you so much. Yeah, I just want to also add my thanks, because I think that this conversation has been really rich. I think that there was just an incredible amount of information offered about how long-term planning and progressive planning is necessary to move this work forward. I'm in awe of the work that has happened in these two communities, especially during this time, working through the pandemic, working through conversations on social and racial justice, and still so much happening and so much that we still have to do. So, this is where we kind of dig deep and we find the joy in what we are doing, and then keep looking at what we will do next. Brianna, are you able to pull up the poll for those of us that are here on the Zoom?
Yep, so I just launched it, so everyone should have access.
Great, you should see some poll questions coming up. And I can't actually see the results, so
We're starting to see things roll in.
So I think our first question in the poll was, what is the sector that you represent? So maybe, Brianna, you can just tell us a quick kind of view of what are those results that you're seeing come in.
Yeah, so our biggest sector right now is government, and closely followed by the private sector, though we have people still jumping in, but mostly we're seeing folks from the private sector and governments. And our second question in the poll is, what did you tune in to learn about today? And we have two tied for that. and cutting edge adaptation examples, and how to apply climate science in engineering and design.
Cool.
And our final question, did you learn something today that you can apply to your climate resilience and adaptation work? And overwhelmingly, folks said yes. So
Hey.
kudos again to all of our speakers today.
Awesome. Great. I'm so glad that people were able to have that experience, that they're getting some of what they're looking for to advance their work. Just once again, as we kind of outro here, we'd love to share more with you about the American Society of Adaptation Professionals. We currently are running a microgrants program for local hubs. If you want to get involved in advancing resilience in your own community, we have an opportunity to participate in that program. We also have our next co-creation webinar series coming up on August 27th. Webinar 2 is going to be on making the economic case for adaptation projects, so I hope that you will join us for that. It has been recorded. It's also been available on Facebook Live. We'll be posting the recording up on our YouTube channel, along with any resources that have been shared via the link and questions that had resources that our speakers may have wanted to share following the presentation. And I really want to thank ASCE for joining us co-hosting the presentation today. I think that the remarks from Ruwanka were really valuable. I look forward to seeing that the failure studies and also looking forward, of course, to the next infrastructure report card. So thank you everyone for joining us, and I look forward to our next conversation on August 27th.